Hello students, good morning. Welcome to our physics online class. In the previous physics class, we have discussed about dimensional analysis. So what is meant by dimension? The dimensions of a physical quantity are the powers to which the units of base quantities are required to represent the derived units of that quantity. Then you have discussed about dimensional formula for various physical quantities. Also, you have learnt dimensional variables, dimensionless variables, dimensional constants, dimensionless constant. Then you have learnt about the principle of homogeneity in dimensions. What is meant by that? The principle of homogeneity of dimension states that the dimensions of all the terms in a physical expression should be the same. And last, you have learnt about applications of dimensional analysis. What are the applications of dimension analysis? Convert a physical quantity from one system of units to another. Convert a physical quantity from one system of units to another. Check the dimensional correctness of the given physical equation. Check the dimensional correctness of a given physical equation. Establish the relation among various physical quantities. Establish the relations among various physical quantities. I believe that you all have learned these questions. In yesterday's class, you have learned about first use with the example. That is the example 1.12. Convert 76 cm of mercury pressure into Newton meter raised to minus 2 using the method of dimensions. It was a very important question. Similar to that problem, the second problem today we can discuss. Example 1.13. If the value of universal gravitational constant in SI is 6.6 into 10 power minus 11 Newton meter square kg raised to minus 2. Then find its value in CGS system. If the value of universal gravitational constant in SI is 6.67 10 power minus 11 Newton meter raised to minus 2 Newton meter square kg raised to minus 2, then find its value in CGS system. So, universal gravitational constant in the SI system is given. We have to find out the CGS system. This question is based on the first use. Convert a physical quantity from one system of units to another. So, solution. What is the formula used here? That is N1 of U1 is equal to N2 of U2. Let GSI be the gravitational constant in SI system. And CGS be the gravitational constant in CGS system. GSI value is 6.6 into 10 power minus 11 Newton meter square kg raised to minus 2. GCGS value we have to find out. So what is the formula we are using? N1 of U1 is equal to N2 of U2. Or else we can write G Si M1 power A L1 power B T1 power C is equal to G CGS M2 power A L2 power B T2 power C. We have to find out the value of GCGS. So we can write GCGS is equal to GSI into M1 by M2 the whole power A L1 by L2 the whole power B T1 by T2 the whole power C. Now let us consider M1 equal to 1 kilogram. So first we are considering as the SI system N1. So we can consider M1 is equal to 1 kilogram, L1 equal to 1 meter, T1 equal to 1 second. Similarly, M2 is equal to, related to CGS system, so 1 gram, and L2 is equal to 1 centimeter, and T2 is equal to 1 second. Now, the dimensional formula for gravitational constant. What is the dimensional formula? Dimensional formula for G is M power minus 1 L cube T raised to minus 2. This is the formula for gravitational constant. M power minus 1 L cube T raised to minus 2. This is already we have seen in the derived quantities table. Comparing the powers, we can write A equal to minus 1, B equal to 3, C is equal to minus 2. Now substitute these values in this equation. Consider this as equation 1. So the equation 1 becomes GCGS is equal to, what is GSI? It is given in the question. 6.6 into 10 power minus 11. M1 by M2. What is M1? 1 kilogram. What is M2? 1 gram. The whole power minus 1. L1 by L2. What is L1? 1 meter. What is L2? 1 centimeter. The whole power 3. T1 by T2. What is T1? 1 second. What is T2? 1 second. The whole power minus 2. Now convert this into CGS system. The value be same 6.6 in 10 power minus 11. And again here 1 kilogram divided by 1 gram can be written as 10 power minus 3 kilogram. So 10 power minus 3 kilogram, the whole power minus 1. 1 meter, 1 centimeter can be written as 10 power minus 2 meter. The whole power 3. Then 1 second by 1 second, the whole power minus 2. So here kilogram get cancelled. We can write 6.6 in 10 power minus 11 into 10 power minus 3. If it comes the numerator, we can write 10 power 3 the whole power minus 1 Meter get cancelled. 10 power 2 the whole cube and 1 get cancelled. That is 1 power minus 2. It is same. So we can write 6.6 into 10 power minus 11 into 10 power minus 3. 3 into minus 1 minus 3 into 10 power 2 3s are 6. So into 1. 6.6 into 10 power minus 11 into 10 power minus 3 into 10 power 6 into 1. So simplify this. 6.6 into 10 power minus 11 minus 3 plus 6. It becomes 6.6 into 10 power minus 14 plus 6. So it is minus 8. And the unit is dyne centimeter square g raised to minus 2. For Newton, dyne. For meter square, centimeter square. For kilogram raised to minus 2, kg raised to minus 2. So the value of GCG is gravitational constant in Gaussian system is 6.6 into 10 power minus 8 dyne centimeter square g raised to minus 2. I believe that you have understood the problem. Example 1.12 and 1.13 are very important problems. Let's move on to the second use. What is the second use? To check the dimensional correctness of the given physical equation, the dimensional formula is used. To check the dimensional correctness of a given physical equation, whether the equation is dimensionally correct or not. Let us take the equation, that is equation of motion. Equation of motion. You have learned V equal to U plus AT, S equal to UT plus half AT square. In that first equation of motion we are considering V is equal to U plus AT. Whether this equation is correct or not dimensionally. So you have to apply the dimensional formula. Apply the dimensional formula on both sides. We will get V is velocity, U is also velocity, V is final velocity, U is initial velocity, A is acceleration, T is time. So what is the dimensional formula for velocity? For velocity the dimensional formula is L T raised to minus 1. So for V and U the same formula. What is the dimensional formula for acceleration? L T raised to minus 2. What is the dimensional formula for time? It is T. Apply this formula in that equation. So equation becomes L T raised to minus 1 equal to, what is the dimensional formula for U? L T raised to minus 1 plus, for A it is L T raised to minus 2 into T. So L T raised to minus 1 equal to L T raised to minus 1 plus, here L T raised to minus 2 plus 1. So it is T raised to minus 1. So L T raised to minus 1. Quantities of same dimensions only can be added. Same dimensions only can be added. See this equation? Dimensions of each term is same. The dimensions of both the sides are same. Hence the equation is dimensionally correct. Hence the equation is dimensionally correct. LT raised to minus 1, LT raised to minus 1, LT raised to minus 1. Let's see one more example related to this concept. Example 1.14. Check the correctness of the equation half mv square equal to mgh using dimensional analysis method. Check the correctness of the equation half mv square is equal to mgh using dimensional analysis method. Solution. So first we should know the dimensional formula for half mv square. Dimensional formula for half mv square. Half has no dimension. Half has no dimension. Then m. For m it is mass. V square. Velocity. So Lt raised to minus 1 the whole square. So it can be written as m L square T raised to minus 2. This is the dimensional formula for half m V square. Since half has no dimension. Next, dimensional formula for mgh. Dimensional formula for mgh. What is m? Mass. So the dimensional formula is mass. What is g? Acceleration due to gravity. So it is the acceleration dimensional formula. What is that? Lt raised to minus 2. H, height. So nothing but the distance. So the dimensional formula is L. So how can we write? M L. L square T raised to minus 2. Quantities of the same dimensions only can be added. Now check this. This is left hand side. This is right hand side. So both are dimensionally correct. ml square t raised to minus 2 is equal to ml square t raised to minus 2. So both sides are dimensionally same. Hence the equation half mv square equal to mgh is dimensionally correct. Students, you have to practice all these examples. Example 1.1, 1.12, 1.13, 1.14. These questions and all frequently asked questions for the public examinations. Very important questions. Let's move on to the third use. What is the third use? To establish the relation among various physical quantities. To establish the relation among various physical quantities. That is, some quantities are given. Based on the problem, you have to find the relations among the quantities. Suppose a physical quantity Q may depends upon the quantities Q1, Q2, Q3. The particular value Q may be depends upon the quantities Q1, Q2, Q3. So we can write Q proportional to Q1 power A, Q2 power B and Q3 power C. So in order to find the relation, we have to frame the formula. So proportionality can be removed. We can write Q is equal to K, Q1 power A, Q2 power B and Q3 power C. Actually, K is a dimensionless constant. The value will be given from the experiment. Constant value. When the dimensional formula for Q1, Q2, Q3 and Q known, we can substitute the formula in this equation. Substitute the dimensional formula for all the quantities. Next step, according to the principle of homogeneity, equate the power of MLT on both sides. According to the principle of homogeneity, equate the powers of MLT on both sides. By equating we will get the values of ABC. After substituting the ABC, we can find out the relation among these quantities. So what is the first step? First step, apply the dimensional formula for all the quantities. Second step, equate the powers of M, L and T on both sides. Then last step, by solving the equations, we will be getting the value of ABC and we can find the relations among the given quantities. Listen the example related to the third use of dimensional analysis. Example 1.15. Obtain an expression for the time period T of a simple pendulum. Obtain an expression for the time period T of a simple pendulum. The time period T depends upon mass m of the bob, length of the pendulum L, acceleration due to gravity G at the place where the pendulum is suspended, and it is given constant k is equal to 2 pi. So we have to find out the formula for time period of a simple pendulum. Also it was given time period depends upon mass, depends upon length, mass of the bob, length of the pendulum, acceleration due to gravity. Also the value of k is given. Let's find the relationship. According to the question, time period depends upon mass of the bob, so m power a, t proportional to m power a, length of the pendulum, so L power b, acceleration due to gravity, so g power c. We can rewrite t is equal to constant into m power a, L power b, g power c. Next step, we have to apply the dimensional formula for all these quantities. So k is a dimensionless constant. And dimensional formula for t is t. Dimensional formula for m is m. Dimensional formula for length is L. Dimensional formula for acceleration due to gravity is L t raised to minus 2. So substitute the dimensional formula in these equations. T. For time it is t. So t equal to, k has no dimension, so no dimensional formula. For m it is capital M. So m power a. L capital L. L power b. G Lt power minus 2 the whole power c. Okay. Now we can rewrite this equation like this. This time has 0 dimension in mass, 0 dimension in length and 1 dimension in time. So m power 0, L power 0 and 1 t power 1 equal to m power a, L power b as well as L power c is there. So we can write L power b plus c and t power minus 2c. That is m power 0, L power 0, t power 1 equal to m power a, L power b plus c and t power minus 2c. What is the next step? Comparing the powers of m, L and t on both sides. Comparing the powers of m, L and t on both sides. We get a equal to 0. Combine the power of m, a equal to 0. Combine the power of L on both sides, b plus c equal to 0. Comparing the power of t on both sides, minus 2c is equal to 1. Minus 2c is equal to 1. So a equal to 0, b plus c equal to 0, minus 2c equal to 1. From this, what is c? C is equal to minus 1 by 2. Substitute the value of c in this equation. So b plus c, that means b minus 1 by 2 equal to 0 or b equal to 1 by 2. So we got all the values. What are the values? A equal to 0, b equal to 1 by 2 and c equal to minus 1 by 2. Comparing the powers. A equal to 0, c equal to minus 1 by 2, b equal to 1 by 2. So substitute the value of a, b, c in this equation. We will get t equal to k into m power 0, l power 1 by 2, b equal to 1 by 2, g power minus 1 by 2, c equal to minus 1 by 2. So we can write t is equal to k into anything power 0 is 1. So l power 1 by 2 we can write as root of l. And g power minus 1 by 2 we can write as 1 by root of g. So we can write it as t is equal to k into root of l by g. Experimentally, k equal to 2 pi. Hence, t equal to 2 pi into root of l by g. So this is the relation of a time period of simple pendulum. Expression for time period of simple pendulum, t is equal to 2 pi into root of l by g. I hope you have understood that problem. Let's see the next problem. Students, you can try along with me. Example 1.16. What is the problem? The force F acting on a body moving in a circular path depends on mass of the body m, velocity v and radius r of the circular path. The force F acting on a body moving in a circular path depends on mass of the body m, velocity v and radius r of the circular path. Obtain the expression for the force by dimensional analysis method. Take the value of k equal to 1. So according to the problem, we can write the formula. The force depends upon mass of the body. So m power a. Velocity. So v power b. Radius r power c. Can be written as F equal to k m power a, v power b and r power c. Obviously the value of k is equal to 1. So it has no dimension also. Substitute the formula, dimensional formula for all these quantities. Let's write the dimensional formula for force. Dimensional formula for F is, what is that? M L T raised to minus 2. Mass into acceleration. Dimensional formula for M is capital M. Dimensional formula for velocity is Lt raised to minus 1. Dimensional formula for radius is nothing but distance. So L. So rewrite the above equation. We can write m L T raised to minus 2 equal to F. K is equal to 1. There is no dimension. M. So m power a. Then what is that? V. L t power minus 1 the whole power b. And L power c. So we can rewrite here m power a, L power b plus c. Here b it is c. So we can write L power b plus c. So this is m, L. And t power minus b. Compare the power of MLT on both sides. Compare the power of MLT on both sides. How can we write? So A, here it is M L T raised to minus 2. So comparing the power of M, A equal to 1. Comparing the power of L, B plus C equal to 1. Comparing the power of T, minus B equal to minus 2. So from this, B equal to 2. B equal to 2. A equal to 1. Then C. B equal to 2, substitute here. We can write 2 plus C is equal to 1. C is equal to 1 minus 2, that is equal to minus 1. So C equal to minus 1. A equal to 1. B equal to 2. C equal to minus 1. Substitute the values of A equal to 1, B equal to 2, C equal to minus 1 in the above equation. We will get F equal to M, that is M power A, B power B and R power C. That can be written as F is equal to M power 1, B power 2 and R power minus 1. That can be written as F equal to MV square by R. So this is the expression for force acting on a body moving in a circular path. This centripetal force F is equal to mv square by R. Students, you practice these problems and learn well. Next, limitations of dimensional analysis. We have seen the uses, now the limitations. What are the limitations of dimensional analysis? This method gives no information about the dimensionless constants like 1, 2, etc. pi, e. So no information about the dimensionless constants in the formula like 1, 2, etc. pi, e, etc. Second point. This method cannot decide whether the quantity is vector quantity or a scalar quantity. This method cannot decide whether the quantity is vector or scalar. Third limitation. This method is not suitable to derive the relations involving trigonometric, exponential and logarithmic functions. This method is not suitable to derive relations involving trigonometric functions, exponential functions and logarithmic functions. There is no dimensional formula for that. It cannot apply for equations involving more than 3 physical quantities. It cannot apply for equations involving more than 3 physical quantities. The last limitation is it can check only whether the relation is dimensionally correct but not absolutely correct. It can only check the relation is dimensionally correct but not the correctness of the relation. For example, S is equal to ut plus 1 by 3 at square. Using dimension analysis, 1 by 3 has no dimension. So we will get the formula. The dimension of all the terms will be same. So this equation is dimensionally correct. But we know that what is a correct relation? S equal to ut plus half at square. So it can only check on whether the physical relation is dimensionally correct but not the correctness of the relation. Okay, students. So the first unit has completed. In this first unit, we have learned scientific method, branches of science, measurement of basic quantities, measurement of small distance using screw gauge and vernier caliper, measurement of large distances using triangulation method, parallax method, radar method, error and its types, propagation of errors, and at last dimensional analysis. Students, today you have to learn these questions. What are the uses and limitations of dimension analysis? Also, you have to practice the examples 1.12, 1.13, 1.14, 1.15 and 1.16. Learn well, students. Thank you.